If you haven't done so already, please go ahead and turn to pages 8 and 9 in your ESRT. When you get there, you should have a page that looks a lot like this. As you open up pages 8 and 9, you're going to see that the information from page 8 connects to the information on page 9. I'm only going to show you one page at a time because if I show both pages at the same time, you really can't see the information really well. What I'd like to do right now is just kind of orient you and get you familiar with some of the features on this page and on pages 8 and 9. Go ahead and look down here at the bottom. One of the questions that this chart answers is how old the Earth and solar system are. Right now, go ahead and circle it, just like I have, just so it really stands out to you. You'll see that it's 4,600. That's actually 4,600 million years. If you look at the top, this scale is in millions of years ago. Please go ahead and circle million years ago. So if the age of the Earth and solar system is 4,600 million years, that's actually equal to 4.6 billion years old. Right now, please go ahead and write that down. 4.6 billion years old, just like I did there. You're going to hear that a lot. You're going to hear me say that, and actually we've talked about that in astronomy. I'm going to go ahead and erase that so I can show you some other things. Go ahead and look down here at the bottom of the chart. Down here in this space of time, where I'm circling right now, and you should circle this too, it says Ediacaran fauna, first multicellular soft-bodied marine organisms. This is during a period of time called the Precambrian. And you can see it's the Precambrian if you look all the way back up here to the Precambrian. Okay? It corresponds to that unit of time. If you think about it, these soft-bodied organisms, right here, it says soft body. Think to yourself, would that leave a good fossil or not? If it's like a squishy, kind of wormy, blobby thing. You're probably thinking no, and you're right. Soft-bodied organisms are going to leave a really poor fossil. So go ahead and write that on here. Leaves poor fossils. Just write it somewhere where it makes sense, where you have room for it. But that's a key concept, is understanding that those early organisms were soft and didn't have any like skeletons to them, either an exoskeleton or an endoskeleton. So it really didn't leave very good fossils. Then you'll notice right here at this boundary, so this boundary here that I'm starting to outline, okay? I can't go all the way up here on the screen, but this dark line represents a boundary. It says, great diversity of life forms with shelly parts. As soon as you get those shelly parts, you can see that there's a huge change in life. These boundaries that you're looking at are based off of changes in life. And that's actually one other thing that I want to point out about this chart and about how it's laid out. I'm actually going to shrink it a little bit so you can see it a little bit better, or you can see more of it on this one screen. You'll notice the units of time are a little bit unique looking on here. So I want you to look between here to there. If you look at this time, you'll see that the Precambrian takes up a huge amount of time, and the Phanerozoic is a much smaller amount of time. There's a problem with this, though. During the Precambrian, very little is happening, and you can see that reflected down here, and then also throughout some of the information right here. So during that Precambrian time, there's very, very little going on. However, during the Phanerozoic, there's a lot going on. So if you look at the Phanerozoic, here's the Phanerozoic, and you come down here and look at this area right here, there's a tremendous amount of activity, tremendous amount of activity in the form of life. So what this chart is trying to do is it's trying to balance two things. It's trying to show you that the Precambrian is a really long amount of time, but that there's not much happening. The Phanerozoic is really where a lot's going on. So in order to show that, what they have to do is they have to expand the chart. So just be aware that the Precambrian, really long amount of time. Phanerozoic, short amount of time, but there's a lot more going on. You can see that on there. So let me erase some of the notations on here and point out a few more things. Go ahead and find the humans. Where are we? When did we first show up? And to do that, you might want to start down here and kind of work your way up. Have you found us yet? Keep going. I'm actually going to go ahead and make this a little bit bigger so it's easier to see. And if you keep going up and up in the timeline here, you can see us right here, humans. We showed up relatively recently. Look at all the history down here. It just goes on and on and on. We've been around for a very short amount of time. If you look, you can see it says 1.8. Or in other words, the humans showed up 1.8 million years ago. That's a short time. We actually showed up during what's called the Pleistocene. Hopefully you can see that on there. Okay. So a few other things I want to point out here. If you look over here, it says New York rock record. Rock record means this is periods of time that we have rocks representing different units of time in New York State. So let me ask you this. If you look at this right here, do we have rock record representing this period of time? Or during the Neogene? And if you look, because there's no bar in there, you know that there's no rock record from that period of time. If you go down here, a little bit further down, during the Paleozoic, so here's the Paleozoic, you can see during the Paleozoic, we start to have a lot more rock record. I'm going to kind of outline it so it's a little bit easier to see. But you can see there's a lot of rock record right here, and there's a little bit right here. These other areas, there's gaps. And if you think back to what we've been learning about in the sequence of events, what's that gap called in the rock record? Are you remembering? It's called an unconformity. So go ahead and label that on here. Like, just kind of maybe put a little arrow on here. This gap is an unconformity. Now I'm not going to label all the gaps on here, but I'm just going to label this one here, just so you know that any gap that you see on here is an unconformity. So there's an unconformity here. You don't need to draw that. Unconformity, unconformity, and so forth. Any of those gaps is a period of weathering and erosion, and the rock has been removed. It's a gap. Okay, so now I'm going to move on to another column, which is on the next page. On this column, it talks about fossils of New York State. What they're looking at is how long different fossils have been around, or how long the organism lasted before it died off. You can see here the trilobites started down here, where there's like that little A, and went all the way up here, and it ended. What geologic period of time did it end? And the way to figure that out is you go all the way over on your ESRT. You can see everything. I can't see it on mine. And you figure out what period of time that is. This right here is called an extinction. Go ahead and label that. Extinction. And then to answer this question about what period of time this is, I'm actually going to look here on this other page where I can see the whole page. This one doesn't really work quite as well. That's why I don't really use it. It's kind of slow. And it's a different version too, I think. So anyway, here's trilobite. It's ending here. And you go across, you can see that the trilobites went extinct at the end of the Permian. Okay, so that's how that works. Also, if you look here, fossil A, this is a type of trilobite that first showed up during the Cambrian. So you can see how the information from one page relates to information on the other page. It's all connected. Now you'll notice that there's letters on there. These letters, like this A right here, corresponds to something in your reference table. And you can see that in your reference table. It's actually a little different looking from this one. So let me go back to this page. You can see that there's letters down here. So that A that I was looking at on the other chart corresponds to the A on this chart. It's going to make it big so it's easy to see. Oops. There it is. So you can see it corresponds to this fossil right here. It's called the Leptocephala. So when you see those letters, you know it refers to those. Okay. So a few more things, and then you guys can start working on that worksheet. Important geologic events in New York. So as you look at this, there's a few words on here that I kind of want you to understand. Here's one. Orogeny means mountain building. So go ahead and label that mountain building. All right. Then over here, last column talks about inferred positions of Earth's land masses. You guys might remember this when we talked about Alfred Wegener. He came up with a theory of Pangaea. So as you look at this, you can actually see the movement over the millions of years of the different continents. And sometimes you get questions about this. It's not like really common, but you can see bit by bit how the continents have moved over the years. So there's a lot of information on here, and the key is just to keep looking. What I've tried to do in the worksheet is organize it in a way where you're, the different questions are grouped by category based off of the different headings on the top of the reference table for pages 8 and 9. I'm sure the teacher today can help you out with that, and good luck to you. Thanks.